Okay, so I want to do 5.4, which is about indefinite integrals. And remember, indefinite integrals are nothing but antiderivatives. And what we call the net change theorem. Before I get to examples about indefinite integrals, let's review all the indefinite integrals rules. Review of indefinite integrals rules. So the first one is if you have the integral of a constant times f of x, you can pull the constant out. Should know by now that this is true. Integral of k dx is kx plus c. The sum and difference rules, integral of x plus or minus g of x. You can split it up. There's a sum or difference rule, but there's no product or quotient rules. G of x dx. The power rule, that's the most useful one. Integral x to the n dx is you add 1 to the power, divide by the new power plus c. Of course, you're always adding a c, as long as n is not negative 1. If n is negative 1, then you're doing the integral of x to the negative 1 dx, which is the integral of 1 over x dx, and we know this is natural log, because the derivative of natural log is 1 over x. Okay. The integral of e to the x dx is e to the x plus c. The integral of b to the x dx is b to the x, but then you gotta divide by ln of b. If you divide here by ln of e, it's 1, so that's why we don't do that, okay? Integral of sine x dx is negative cosine x plus c, and integral of cosine x dx is sine x plus c. Integral of secant square is tangent x plus c, and integral of cosecant square is negative cotangent x plus c. Integral of secant x tangent x dx is secant x plus c. Integral of cotangent x cosecant x dx is negative cotangent x negative cosecant x plus c. Integral of 1 over 1 plus x squared dx is tangent inverse x plus c. And rule number 15, integral of 1 over square root of 1 minus x squared dx is sine inverse x plus c. That's all we have to do, okay? So now, for example, if we're doing number 10, page 415, the integral of the fourth root of x to the 5. So now we can write this as a 4. This is integral of x to the 5 over 4, which x to the 5 over 4 plus 1. That's 9 over 4, divided by 9 over 4 or times by the reciprocal. So it's 4 over 9 x to the 9 over 4 plus c. Number 14, page 415. Integral square root of t times t squared plus 3t plus 2. We don't have a product rule, so we gotta distribute. This is t to the 1/2. We distribute that, so the integral of t to the 3/2, 5 halves dt, split it up, pull the constant out, t to the 3/2 dt plus 2 integral of t to the 1/2 dt. So add 1 to 5 halves, 7 halves, divide by 7 halves or times by reciprocal. 3t 3/2 plus 1, 5 halves times 2/5, and then 2t to the 1/2 plus 1 is 3/2 times 2/3 plus c. Let's clean it off a bit. So there's nothing to be done here. This would be 6/5 t to the 5/2. This would be 4/3 t to the 3/2 plus c. Okay, number 16. Integral of secant t times secant t plus tangent t dt. So if we distribute, we get integral of secant squared t plus integral of secant t dt, tangent t dt. Secant square is tangent t, and secant tangent is secant t plus c. Let's do now definite integrals. Page 415. The integral from 1 to 2 of 4x cubed minus 3x squared plus 2x dx. So this is 4 integral of 1 to 2 x cubed dx minus 3 integral from 1 to 2 x squared dx plus 2 integral from 1 to 2 x dx. So this is x cubed over 4 times 4, x to the 4 over 4 times 4 is x to the 4. X cubed over 3 times 3 is x cubed. And then x squared over 2 times 2 is x squared. Now we're going to put the limits according to the fundamental theorem of calculus, part 2. We plug the upper limit first. So we plug the 2. So 2 to the 4 is 16, 2 cubed is 8, 2 squared is 4, and then minus, plug the 1 in. 1 minus 1 plus 1. That's 12 minus 1 is 11. Let's look now at 32. Integral from 1 to 2 of 1 over x squared minus 4 over x cubed dx. So now we want to write them as power, so move them up and then split it up. 1 to 2 x to the negative 2 x minus 4, 1 to 2 x to the negative 3 dx. So we add 1, x negative 2 plus 1 over negative 2 plus 1 minus 4. Again, x to the negative 3 plus 1 over negative 3 plus 1. We're going to do 1 to 2. So that's x to the negative 1 over negative 1 or negative 1 over x. That's a negative 2. Negative 4 divided by negative 2 is 2. X to the negative 2 at the bottom, it's x squared. 1 to 2. So if we plug the 2 in, negative 1/2 plus 2 over 4 is 1/2 minus, plug the 1 in there, negative 1 over 1 plus 2 over 1. So it's going to be negative 1. Okay. Here's another example. This is not from the book. 0 to pi over 4 secant theta tangent theta d theta. So we know the antiderivative of secant tangent is secant, so secant theta, and then we're going to put limits according to the second fundamental theorem of algebra. We plug the upper limit first, so secant pi over 4 minus secant 0. Secant pi over 4 is root 2, and secant 0 is 1. 46. Page 416, number 46. Integral from 0 to pi over 3 sine theta plus sine theta tangent square theta divided by sine square theta. You know, I always tell my calc students, you do your algebra, you do your trig first, then the last thing is your calculus. Okay. At the bottom it's secant square, sorry, secant square. So please fix that, secant square. Okay, if you look at the top, we could pull out a sign, and I'll tell you why I want to do that, because it's 1 plus tangent square. And 1 plus tangent square and secant square are the same, so we can cancel them out. So we're only doing 0 to pi over 3 sine theta d theta. Okay, because remember 1 plus tangent square, the identity is secant square. That's why I could cancel out secant square with 1 plus tangent square. And integral of sine theta is negative cosine theta between 0 and pi over 3. We put the upper limit first, negative cosine pi over 3 minus negative cosine 0. So cosine pi over 3 is 1/2, negative 1/2, and then plus cosine 0 is 1, so this is just 1/2. 52. So if we're doing the integral from 0 to 2, absolute value of 2x minus 1 dx. So when they do absolute value, that means they want the area under the curve, okay? Area under the curve. Under the curve, f of x equals 2x minus 1 over 0, 2. So let me just explain that. If you graph it so you can see what I'm going to do. F of x equals 2 minus 1 between 0 and 2. F of 0 is negative 1. F of 1 is 1. And f of 2 is 3. So it's this, and they want, this is a 2, this is a 1, so they want this area, which is, this is actually 1/2, right? Because 2x minus 1 equals 0, 1x equals 1/2. So we're going to split it up for two areas, between 1/2 and 2 where it's positive, and then between 0 and 1/2 where it's negative. But we can, so to get the area, we gotta flip it. So we gotta do, we're gonna find this much, and this is gonna be negative 2x minus 1, right? It's the opposite between 0 and 1. So this is gonna be the integral from 0 to 1/2, the opposite of 2x minus 1, plus 1/2 to 2, exactly 2x minus 1. You should always do that when finding area. If graph is under the x-axis, you're going to flip it, so you do the opposite on that interval. If it's above, you do the same. Okay. So this is actually negative 2x plus 1. This, okay, so to integrate it, we're going to do them separately. Integral of negative 2x plus 1 is negative x squared plus integral of 1 dx. This is going to be evaluated between 0 and 1/2. This is Integral of 2x dx is x squared minus integral of 1 dx is x, but this is between 1/2 and 2. So this would be, you plug the 1/2 in, you negative plus 1/2 minus you plug the 0 in, you plug the 2 in, that's for minus 2, minus you plug the 1/2. So this comes out to be 5/2. There's, you can check this on your grapher, but you gotta learn how to do it on the test. There's definitely something like this. But look how you could. So you could do y equal, let's clear what I have in there. Absolute value, so you go to math, number, absolute value of 2x minus 1. And graph it. So you can see, I want to show you a better picture than this, so I'm going to go to window and do -6 or -5 to 5 on the x value and say -6 to 6 on the y value. Oh, that's 1, -6 to 6. So you can see how it flipped the graph between 0 and 1/2. Now we want to do, so we want to go to second calc, which is second calc. You can see the integral is number 7, and the lower limit we're doing from 0 at enter. The upper limit is 2 at enter, and it's going to shade the area, and it's going to give you the answer at the bottom, which is 2.5. And that's exactly what we just did. Okay, again, you need to do the math and then use your grapher to check your work. If you only show me the answer, you're gonna get 0 on the test. So I hope you realize that. Number 58, page 416. Page 416, or 17, page 416. The boundaries of this shaded region are the y-axis, the line y equal 1, the curve y equals 4th root of x. Find the area of this region by writing x as a function of y and integrating with respect to y. So we have y equals 4th root of x. To write x as a function of y, you do 4. So x is y to the 4. To integrate to y, so you're doing the y values from 0 to 1 and y to the 4 dy, which is y to the 5/5, and that's just 1/5 minus 0, which is 1/5. Okay, so the next result is what we call the net change theorem, which is exactly the second fundamental theorem of calculus, but this is just for applications. The integral of the rate of change, the integral of a rate of change is the net change. So the integral from a to b f prime of x dx, remember the fundamental theorem of calculus said you find an antiderivative of that, which is going to be f of x, you plug the lower limit, and that gives you the net change. And if you look at pages in my notes, they're the wrong pages, so please fix them, 412 and 413 in your text. Again, fix those. 412 and 4, it shows you all the applications about the net change theorem. Of course, we're not gonna have to worry about all of them. Like here's, if you look at the bottom of page 412, if V of t is the volume of water in reservoir, then its derivative is the rate at which water flows in the reservoir, and the integral of the derivative is the net change and the amount of water in the reservoir, and so on. There's the concentration of chemical reaction, there is mass of rod, if you do density, then m minus m of a. If I give you any of these, I will explain it on the test, okay? So an example that I want to give you is number 70, just one example. If I give you a test question, it will be a test question along those lines. 70, page 416. It says the velocity function in meters per second is given for a particle moving along a line. Find the displacement and then the distance traveled by the particle during the given interval. And if you want to read more about displacement, it's on page 413, number 2, and it says right there. It says if an object moves along a straight line with position function, then its velocity is, of course, the derivative of position. And integral of v of t, s of t2 minus s of t is the net change of position or displacement of the object during the time period from t1 to t2. If we want to calculate distance, displacement goes back and forth, so positive and negative. Distance is always positive. Then if you want to do distance, the velocity has to be positive. The object moves to the right, also negative. The object moves to the left. In both cases, this is computed by. So to make sure that velocity is positive, we do absolute value to get this travel. Okay? So when you do displacement, you could get positive or negative. You can see you here, A1 positive, A2, A3, that gives you displacement. But if you get distance, then A2, you have to flip it. Okay? You have to flip A2 to make it positive. Okay. So number 70. Let's go back to number 70. It says find the displacement. So we're given v of t equals t squared minus 2t minus 3, t between 2 and 4. So to find part A, displacement during that time interval, displacement, it's going to be integral from 2 to 4 v of t dt, 2 to 4 t squared minus 2t minus 3 dt. So integral of t squared is t cubed over 3 minus integral of 2t is t squared minus 3 integral of 1 dt is t between 2 and 4. So it's 4 cubed, 64 over 3 minus 4 squared is 16 minus 12. And then if you put the 2 in there, that's 8 thirds minus 4 minus 6, and it comes out to be 2 thirds. And that's in meters, I believe. Yeah, because velocity is in meters per second. So then we want the distance traveled. So that's when you have to do absolute value. So the distance traveled by the object integral from 2 to 4 absolute value of v of t dt, 2 to 4 absolute value of t squared minus 2t minus 3 dt. So if you look at the interval between 2 and 4, for y equals t squared x squared minus 2x minus 3, and then if you graph it, you can see between 2 and 4, from 2 to 3, and then 3 to 4. So the part is negative and part positive. So if you do the integral from 2 to 4, which we just did in part A, it gave us the 2 thirds, and it gave us the negative plus the positive. Now we want both to be positive, so we want to go and do absolute value. So we're going to do math number, absolute value of t squared or x squared minus 2x minus 3, and you know what I'm gonna do here. Let's delete what it's in there. So graph, so you can see the negative portion, it's gonna flip it. Yeah, but we only need between 2 and 4, so let's go to window and do x minimum is 2, x maximum is 4, and then the y, let's do -2 to 10, so we can see the graph that we want. So it shows you the positive part between 3 and 4. Okay, do the math now. So you're gonna do 7 from 2 to 4. It shows you all the positive part. So it flips at 3. So 11.0667. Let's do the math. So it's from 2 to 3. When it's negative and you flip it, so you do the opposite. And then from 3 to 4, where it's the same because it's already positive. That's why you need to graph it to see. So this would be negative t squared plus 2t plus 3. This would be t squared. Okay, so it'd be negative t cubed over 3 when we 8 plus t squared plus 3t between 2 and 3. Plus this would be t cubed over 3 minus t squared minus 3t between 3 and 4. So this is negative. If you plug 3, 27 over 3 is 9. 3 squared is 9. 3 times 3 is 9. Minus, plug the 2's. Negative 8/3 plus 4 plus 6. Plug the 4, 64 over 3 minus 16 minus 12. And then plug the 3. That's 9 minus 9 minus 9. So we get 9, and that's 10 minus 8/3 plus 10. 10 is 30 over 3. So that's 22 over 3 minus 22 over 3. This would be 64 over 3 minus 28 over 1. So times 3. So 64 over 3 minus 84 over 3 is negative 20 over 3. And then plus 9. So 9 plus 9 is 18 minus 42 over 3. So it's about 11 point something. 18 minus 42 over 3. No. 18 minus 42 over 3 is 4. So I came out with 4. I probably made a calculation error. Let's see if we can find it. So this would be negative t squared plus 2t plus 3. So that's negative 2 cubed over 3 plus t squared plus 3t, and that's t cubed over 3 minus t squared minus 3t. Plug the 3, 27 over 3, 9, negative 9. Plus 9, plug the 2. 2 cubed is 8 over 3. 2 squared is 4. 3 times 2 is 6. That's good. 4 cubed is 64 over 3. 4 squared is 16. 3 times 4 is 12. And then plug the 9. The 3, 27 over 3 is 9. 3 squared, 9 minus 9. So we get 9. Negative 8/3 plus 10. 10 over 1 times by 3, so 30 over 3 minus 8 is 22 over 3. And it's plus. That's the problem right there. Okay. It's a plus, but then that minus makes it a minus. So, yeah. 64 over 3 minus 28. Okay, let's do that. What's 64 over 3 minus 28? It's negative 6.67. And we have minus negative 9, so it's 9. So we have, so we have a 9 from this, and then minus 22 over 3 from the second one, and then minus 6.67, and then minus 9. No, plus 9. So it's 18 minus 22 over 3 minus 6.67. It's about 4. Yeah. Okay, this is what I'm getting. So, all right, so check the numbers anyways. But that's how the problem is done. Let me check the calculator one more time. Oh, I see why. It shouldn't be a square. I put a square there by mistake. So my answer is right. It's just the calculator. Let's clear that. So now we can go to graph. There's the graph. Okay, much better. I had a square by mistake, so calc. Let's go to calc. And then the integral from 2 to 4. So it is 4, and I was right. Okay. Alright, that's it for section 5.4. Until 5.5, have a good day.